Our project is Movie Success Prediction System. We are a team of 3 members. The first person is Jagdish Avaru, I'm Harita Tammana, and my friend Manogna Aruganti. The outline of our project is we'll first talk about the introduction, related work, proposed work, application overflow, data preprocessing, random forest regression, support vector machine, k-nearest neighbors, performance evaluation, demo and results, future work, and conclusions. The motivation of our project is movie making involves highly variable revenue stream. Filmmakers, producers may incur huge losses if the film does not do well at the box office. Um, for the success of a movie or a failure of a movie, there will be many factors which will be influencing. Factors such as director, cast, budget, gross, release year, etc. So, in order to predict the rating and whether a movie is going to be successful or not, what contributes to the success of a movie? The problem definition of our project will be given a movie's important parameters, we predict the movie's success and rating. For this, we use data mining for prediction. In this process, we'll be building a predictive model by having a list of previous movies. And we are mainly using 3 classification algorithms, that is random forest, support vector machine, and k-nearest neighbors. We are trying to predict a given movie whether it is bad, good, or average. Now, when coming to related work, we'll be discussing about 3 related works of our project. The first one is early predictions of movie success, the who, what, and when of profitability. In this, they have concluded that the success of a movie is based on who are in the cast, what the movie plot is on, and when the movie is released. The second related work is a data mining technique for analyzing and predicting the success of movie. In this, they built a predictive model using k-means clustering and decision trees based on attributes which are relevant to the success of movies. The third one is movie popularity classification based on inherent movie attributes using C4.5 part and correlation coefficient. In this, they developed a classification scheme and concluded that average rank of directors contributed most significantly to the success of a movie, followed by budget and actors. The proposed work is we develop an interactive GUI application where we compare the performance of classification algorithms such as random forest classifier, support vector machine classifier, k-nearest neighbors, and we predict the movie success. Our application will allow pre-processing on the initial data sets and modify the data set in a meaningful way. That is, we handle missing data, and the feature selection is done based on correlation matrix. Choosing suitable features as a measure of movie success, like rating movie success. About application workflow. Our input here is IMDb data. As the data has many missing values, we'll have to pre-process the data. So during the pre-processing stage, we will replace the numerical missing data with the mean and categorical missing values with the mode. We do feature selection by taking the correlation between the attributes. By taking existing tools in our programming language, we implement random forest, support vector machine, and KNN models using trained data. Based on accuracy, ROC, area under ROC curve of test data, we evaluate performance by using test data. Now we use user interface to build random forest and SVM for predicting data.
This is Manogna. From next slide, I will be discussing. In this, we'll do data pre-processing. Before doing data pre-processing, we'll find the missingness of the data. Here we can see the proportions of missingness of data. We can see that gross has high amount of missing values, and all these missing values are replaced with mean and mode. For example, like for numerical data, the missing values are replaced with mean, and categorical for categorical attributes, missing data are replaced with modes. Here we can see data visualization of IMDb score and content rating. Here IMDb score is distributed based on the content rating type. Here we can see that TVPG has less variance in the IMDb score, and TVG has more interquartile for IMDb score. After this, we find correlation between the attributes. Here we can see that there are lots of highly correlated attributes in here. Like for example, actor 1 Facebook likes are highly correlated with cast total Facebook likes, and number of voted users are highly correlated with number of users for reviews. Likewise, all these highly correlated attributes are removed. This is because highly correlated attributes are not good for modeling. For example, in this we use random forest. It can be good at detecting interactions between different features. However, it may mask features interactions if the attributes are highly correlated. So we remove all these highly correlated attributes. After removing all highly correlated attributes, these are the remaining attributes that we are considering. Here we can see that these attributes are not highly correlated. Apart from these attributes, we also include two categorical attributes in modeling. Those are country and language. Here we are not including these attributes because correlation we cannot find correlation between categorical attributes. Now we do modeling. For modeling, we take three different algorithms. First is random forest. This random forest is used to build decision trees based on randomness. Here we build multiple decision tree and merges them together to get more stable and accurate prediction. Here and it can be used for both classification and also for regression. Here we can see the example of random forest, how it is built, how it is split based on the randomness, and these splits are based on the parameters given. Here we consider different parameters like minimum number of sample required to split a node, a maximum number of depth allowed for each decision tree, biggest contributor, number of decision trees, higher numbers which are used to reduce variance, and higher number of trees combined with high maximum depth. By using all these parameters, we can get better results. Next modeling feature is support vector machine. It is a supervised machine learning model and it is used for classification. Here the data is split based on the hyperplane. Here we can see that blue circles are on one side and red circles on the other side. These both are split based on the hyperplane region. Here, since there are only two classification types, it is split with one hyperplane. For multiple classifiers, it is split by using multiple hyperplanes. And next we use k-nearest neighbors. Here it is simple and easy algorithm, and it's also used for classification and regression. Here it calculates number of nearest neighbors of a given type. In our application, we used k nearest neighbor by taking 35 k nearest neighbors. Now we do performance evaluation. After building a random forest, SVM and KNN model by using trained data, now we use test data to predict the performance evaluation of the model. For predicting the performance evaluation, we use three of these features: accuracy, receiving operating characteristic, and area under curve. In accuracy, it provides how accurately the model predicts the output when test data is given. In ROC curve, accuracy checks the performance between actual and predicted, whereas for ROC curve, it checks predicting for both false positive and true positive rate. And in AUC value, it is also important because ROC curve does not give exact figure of how much area it is occupied. By using area, we can determine clearly and compare different models. Higher AUC values, better the performance of the classifier. Now, in this slide, we can see the accuracy of KNN, and this is for training data. Here we take 24 nearest neighbors out of in this we can see KNN model. Here for k equals to n, the model accuracy is after performing modeling, Here we can see how efficient the model is. Here we can see the highest accuracy for trained data, and which is 0.67, that's 67%, and it is at k equals to 35. We get 67% of accuracy. This is for training data. We can see KNN model. We are predicting the test data. Here for predicting the test data, we will get accuracy of 68%. And this is the ROC curve. ROC curve, this shows a curve between false positive and true positive. And for this, the area is 0.61. And after this, we do SVM. For SVM, we get accuracy of 70%. And this is the ROC curve of SVM, for which we'll get 0.72 area. And next we do random forest, for which the accuracy is 75%. And now here we can see the ROC curve and AUC. AUC for this, here the area for random forest is 0.71. Here we do comparison analysis for all the models. First we take accuracy for comparison. Here we can see that this one is for KNN, SVM is this, 2 is for SVM, and 3 is for random forest. Here KNN gets least value and random forest gets highest value of 75%. And now we compare areas for all the three models. Here least value is for KNN, which is of 0.61, and next SVM and random forest, they both get similar kind of areas with 0.03 of difference. Hence, after doing all the analysis, we can see that accuracy is good for KNN, accuracy is good for random forest, and area under curve is good for both SVM and random forest. Hence, we can say that random forest is more good comparing to KNN and SVM, and SVM is also good comparing to KNN. As random forest is good, we'll take the rankings of different attributes, that is how attributes are influencing the model. Here we can see the duration is influencing the model, and next class total Facebook likes, and then gross, and then directed Facebook likes, and so on, etc.